Let's make a candle that will burn in outer space. Alternatively, you could call this a hybrid rocket engine, if you're into that sort of thing. Let's go! So picture this. I'm an astronaut floating in the emptiness of space all by myself, and fairly quickly the infinite darkness starts to take a hold, and I feel like, you know what? I would really like a candle. A candle will be so nice, I can just warm myself on it and it'll keep away the darkness. So I pull out my candle and I pull out my lighter and nothing happens. There's no even spark from the lighter. The candle will never ever light in outer space. Why is that? Well, I start thinking about it and I remember, oh yeah, the fire triangle. So the fire triangle is a triangle, a handy reference that reminds me, what do I need in order to make a flame? I need fuel, well I have that with the candle, and I need heat, well the strike pad on the lighter should provide the heat, but I need oxygen. So in order to make a flame in outer space, I need to somehow provide oxygen to this candle. Now I don't want to sacrifice my own breathing air just so that I can have a candle, because that would end badly. So what do? Well, we're going to make our own oxygen using nothing but hydrogen peroxide and yeast. Let's head back to the lab. We're back into an oxygenated environment, which means something that should be said now before we get going. Don't try this at home. This is for educational purposes only and helping you to remember some of the cool science that we're doing today. This is playing with fire, so if you're doing this, make sure you have really responsible people and you do this in a well-ventilated area with nothing flammable around. Okay? Good job. Stay safe. We have oxygen in the air around us. So we can take a candle and a lighter and simply light it on fire. Now, this is because we have as our fuel source, one side of the fire triangle, as the wax in the candle. The heat is provided by the lighter, and the oxygen in the air provides the oxygen needed to create a fire. So voila, we have made a fire. But this would not burn in outer space. In order to create our own oxygen, we have to start with something with oxygen inside it. So we're going to use hydrogen peroxide. Now, hydrogen peroxide is H2O2, which means there are 2 hydrogen atoms and 2 oxygen atoms inside of this liquid. So if we were to pour some of this hydrogen peroxide into a jar, and we'll just pour a decent amount in. Oh, empty the bottle. This is a good one. All right, so we have some H2O2 inside of this jar. And we can put some yeast inside of this hydrogen peroxide. Now, yeast is an organism that has a chemical called catalase in it. And what catalase does is it actually breaks apart hydrogen peroxide into H2O, which is water, and 1 oxygen. And that 1 oxygen will be released as oxygen gas bubbling up out of solution. So let's try this and we'll show you what happens. So there we go, I have a little bit of yeast here. I'm just going to pour it in. Now instantly we see some bubbles showing up. Now something that is kind of as a byproduct, this is an exothermic reaction. So this is actually warming up slightly as it bubbles up. Now I have this on my stirring plate, so I'll just stir it up so we get a nice good reaction. Now these bubbles that are coming up out of this solution is pure oxygen. And we've successfully turned a liquid source of oxygen into a gas. Let's turn that off. Doesn't smell very good. But right now we have pure oxygen come bubbling out of this container. And that is the oxygen side of the fire triangle that we're going to use to make a candle in space. Now, for the next bit of our candle, we need to cover the fuel source. So we do need something to actually burn, because oxygen doesn't burn, it just oxidizes. You need a fuel source to actually make a flame. So we're going to be using pasta. So pasta is a complex carbohydrate and is an excellent fuel source, especially when there's an environment that has a high amount of oxygen, like pure oxygen. So the next step is to create a delivery system so that we can have pure oxygen flowing past our fuel source and then with a source of heat, light that on fire. And that is going to be this. This is just a lid that I've punched a hole straight through. So when we put this on top, we can screw that on. And then when we place the pasta here, the pure oxygen gets funneled through the rigatoni pasta. And then when we light this on fire, it creates its own fuel, heat, and oxygen. And this is the candle that will burn in outer space. Let's give it a go and try it out. All right, we're going to put in our hydrogen peroxide. That's probably a little bit much, but that's okay. And now the yeast. All right, now we can put on the lid. Now I probably put in a little bit too much, but that's okay. All right. And there we have it. We have a self-sustaining flame that would power itself even in outer space. That's so cool. We have oxygen from the hydrogen peroxide. We have fuel from the pasta. And we have heat just from any spark at all or electrical trigger. Look at that beautiful flame. Isn't that amazing? Wow. That is absolutely incredible. Now, I mentioned before that this can be called a hybrid rocket engine. And that's because, in essence, that's what this is. This is a rocket engine. So all you need to do to create thrust is to have a nozzle attached. So if I were to put some rigatoni inside of a copper pipe, oh, sorry, there we go. I've already done this experiment once before, so there's kind of some leftover charred remains in there. So if I were to put this copper pipe over top of that hole and then put this fuel source inside of that, this would be creating thrust. So if you're floating in outer space and you managed to create this, you could use this actually as a thrust engine, as a rocket engine to fly around space. If you're stuck in space, I do not recommend doing this. In fact, I don't recommend you doing this ever because you're playing with fire. So be safe, be smart, and don't play with fire, kids. Beauty. This is Destructive Creativity, and I am Jonathan Allers. If you enjoyed this, make sure you click that subscribe button and smash that like button. Oh, and hit the bell icon too. Apparently I don't say that enough. See you next time. Bye!